Hello everyone, welcome to a new video of Dr. Cat Code. In this video, I'm going to talk about space complexity and time complexity trade-offs. These two concepts are very important in data structure and algorithms, and they always go hands in hand. In this video, I'm going to talk about the relationship between these two important concepts. For those of you who don't know me, I'm Dr. Duy Phan. I have been programming for more than 20 years and I have been teaching at multiple top-tier universities for more than 10 years. I love building products and creating content that are useful for the community. If you stick around until the end of the video, I will show you 3 practical examples demonstrating this idea clearly, along with Python source code. Let's look at the definition first. Because there is no free lunch, it is impossible to get something for nothing. Therefore, the space-time trade-off is a fundamental concept in data structure and algorithms, which is used to describe the following common behavior. The memory usage of an algorithm could be reduced by using more computational time, or vice versa. If you look at the figure that I have drawn here, the idea will be more clearly illustrated. The space complexity and the time complexity. If we have more space to store intermediate result or calculation, it's very likely that we can leverage that and reduce the computational time. On the other hand, if we want to skim on the amount of memory to store the calculations, which means we reduce the space complexity, it's very likely that it has to be paid with the increased time complexity. Okay, so I hope my illustration here is clearly demonstrating the idea of space and time complexity trade-offs. Let's jump right into the examples. So the first example is the comparison between list and generator. These are 2 ways in Python to store or to interact with a series of numbers. List basically require a chunk of memory to be allocated at the beginning to store the n elements at once. So it requires the space complexity of O(n). However, after that, the access time to each element is constant using the index. Given the index, you can instantly access the element at that particular position. On the other hand, generator doesn't actually require massive amount of space at the beginning to store all the elements, because elements are actually generated on the fly for generator. So the space complexity is just O1. On the other hand, time complexity is O(n). Because the way it is getting the item is through generating one after the other. So to get an element at a particular position, you need to linearly generate all the elements before you can reach to that particular element that you want to get. So as you can see here, it's clearly demonstrating the space and time trade-offs. You have more space, you have less times, and you have less space, but you need more time. Okay, so I have written the Python code here demonstrating these 2 ways of interacting with series. For example, I have a series of 100,000 numbers, and this is the list comprehension to generate all those numbers in a list of numbers. So that takes space O(n), whereas the access time for the number at position number 2 or index 2 is just O1. On the other hand, for generator comprehension, I create a generator here also using this definition, but none of the number has been generated yet. So the space complexity is O1. To get the number at the position number 2 though, it means I have to go through the first number and the second number I need to generate those two numbers first before I can get to the third number, which is at index number 2, because index starting from 0. So next. So it takes time complexity of O(n) to get to where I want to. So, yep. So if you think these videos is clear and useful and easy to understand, make sure to like and subscribe and share it to your friends so that everyone can learn together. Also, subscribing to the channel give me a big motivation to keep producing useful content for the community. Also, make it easier for you to see the next video from me timely. So, example number 2, Fibonacci sequence. I have demonstrated these two functions before in my dynamic programming video. However, in this context, I want to talk about the space and time trade-off. Without the use of memory to store the intermediate result, the Fibonacci sequence using symbol recursive function over here require the time complexity of O to the power of n. And the space complexity is still O(n) because of the way we do the recursive stack. So how to improve this? Because the time complexity is really bad. So with the trade-off of adding a chunk of memory, a cache, to store the intermediate Fibonacci numbers for the previous calculation, so that we don't need to calculate them again using memorization. Basically, it's an array of pre-calculated results, and so that you keep them, and then later on, if you see them again, you can just instantly return it instead of calculating it again when it's not none. Okay, so obviously, apart from all these stack call, which is O(n) already, I have another O(n) for storing the intermediate Fibonacci calculation. So there's an extra space required. However, I have managed to reduce the time complexity from exponential time to linear time, which is which is a massive improvement. As you can see here, the trade-off is worth it. So it's important to see the trade-off between space and time complexity to decide, depending on the application and depending on the situation, to see which one is the better one. Okay. Thank you for sticking around. There is one more example, and make sure to like and subscribe so that you can see the next video more easily. Thank you. Example number 3, hash table versus arrays. So these are two classic data structure that we use all the time. They have space and time trade-off as well. That also corresponding to the different situation where you use these. So in Python, hash is basically a dictionary. It consumes more memory because you need to store the key value pairs. Arrays, on the other hand, it uses less memory, but it has slower lookup times. For dictionary, the space complexity is O to the power of n, O2 times n. Sorry, O2 times n. It's still linear, but it needs a bit more space to store the key. So not just the value, it needs to store the key for lookup. Thanks to that, the lookup time is for the time complexity is just O1. This is instant lookup time, which is depending on how dense your hash table is and how good your hash function is as well. But in average, it's normally instant access time. We get into those details of hash table later in another video, but for now, you can see that because of the way we store the key value by hashing the key, we can find the location of a value instantly, and then that is access time is O1. On the other hand, the array doesn't require much more. It's still linear O(n). O(n) is less than O2 times n, but they still both linear. It does spend less space. However, the lookup time is obviously O(n), because to find a particular element, you need to iterate through the list and find it. over here, I have written the Python example. The first one, I'm using a dictionary of key values and with the name and the corresponding score. The names are the keys and the score are the values. To get a particular score of a particular student, I just use the dictionary.get and then passing in the key, and then it will return the value. On the other hand, with list, I need to have one list to store the names and one list to store the grade. To look up a grade of a particular student, I need to find the index of that student. And to find that particular student, it costs me ON to linearly search through the student names and find that particular name so that I can get the index of that name. And then from there, I can get the corresponding grade based on that index. So I spent for this particular example, because the nature of name is the keys and score is the value, actually it's better to use the dictionary compared to the list, because the lookup time is much better. And normally for this particular application, you need to look up a lot. Okay, I hope you learned something today. So to summarize, both space and time complexity are two important concepts to consider when you design your algorithms for your software, and it is depending on the application to make the trade-off to decide whether you want to focus more on saving time or focusing more on saving space. A lot of applications, they probably focusing more on saving time, because in some particular system, the memory is not expensive. But for some particular application, you may want to do the trade-off on the other direction. All right, thank you very much again for watching, everyone. Make sure to like and subscribe to the channel if you haven't done so, to make it easier for you to see the next video from me. That's it for now. Take care. See you in the next video. Goodbye.